Okay, so today we are doing a quick review of 3.3 and then we are going to get into 3.4. As I said, we did not finish it last class, so we'll probably finish it the next time I see you guys. The one review I want to do is the log roll. So that's what I call moving from logarithmic form to exponential form. Some math teachers might call it something different, but I like it this way because it's actually describing the action that you take. So log roll, if I have, let's say, log base b of y equals x, so I just made up those numbers. When we log roll, you start with the first number you see or the base, and then we roll under the equal sign and then back through the middle. It makes this little e, and e helps me remember I'm going to exponential form. So the e in the log roll means I'm going from log to exponential form. When I write this, I write it as the first number I see. So I touched b first, then I touched x, and then I touched y. So b to the x equals y. So that's just kind of a motion we're doing over and over. We did a ton of practice on this, so you might remember it and be like, Ms. White, we didn't need this review, but I just wanted to make sure we remembered it if we didn't. The couple I want to practice, so I'm not going to the first page to practice anything on the front side because I think that we're good enough on that, but I do want to practice a couple that don't have the bases physically written in. I want to remind us that if it's log with no base, then we assume that it's a log base 10. So log base 10 of x equals -2. So 10, and then we do our log roll. So 10 raised to the -2 equals x. 10 to the -2 equals x. I picked this one to do because it helps us remember some exponential rules. So if you have a base raised to a negative exponent, that means that we flip our fraction, we do the reciprocal of that. So I do 1 over 10 squared equals x. And then we can finish that problem by doing actually what 10 squared is, and 10 squared is 100. So 1 over 100 equals x. Ooh, that's not what I wanted. All right, that's as good as we're gonna get today. Whatever. Okay, so 1 over 100 equals x. Let's do letter E. E is an elephant. Funny how that goes around. If it's ln of x equals 6, that's the same thing as having a base log with a base of e. E is a number. It's like 2.781 something, something, something. And it goes on and on forever. It's a lot like pi. And so E is a number that we're going to see a lot more often. Remember that ln means natural log. And you don't have to rewrite it as log base e. If you look at the one above, I just wrote like a little e underneath that ln. Technically that's incorrect notation, but I don't want to rewrite it. I just want to remember that e is the base there. And so I did e, and then I did my log roll from there. So again, you don't have to fully rewrite it. You can just put like a little e here and call it a day. So let's log roll. I've got e raised to the 6. Ooh, I forgot my x. What? First things first, if you copy your problem, make sure you actually copied it right. So I'm doing e raised to the 6 equals x. And since e is a number, we can put this in the calculator and solve, but I'm okay with you leaving it here. I said that on the quiz that we took. I've said that in the last notes. I'm okay leaving it as x raised or e raised to some number. That is fine with me. The one other problem I want to practice is letter I. I is an ice cream. Also, they're doing some kind of drilling around here, so if you can't hear me, just let me know. On letter I, we've got log base 10 again because it's log with no base. We assume it's 10. I do my log roll. 10 to the 1/3 equals x. If I have 1/3 as my exponent, that means that I'm going to do a radical. So anytime you have a 10 or any number, any base raised to a fraction, it means you have a radical. The number on bottom goes out in front of the radical. It tells you what kind of root we're doing. If it's a square, it's what we always assume. It's just a square root. You don't need to put a number out front. But since 3 is not assumed, we put that out front so we know it's a cube root. I put the base on the inside, and then the numerator, which is 1 in this case, should go with my number. However, any number raised to the first power is just itself, so I don't need to rewrite that. That's redundant as well. So 10 to the 1/3 is the same thing as cube root of 10. Again, I just mentioned 1/2, but let's review. So if I had like 2 to the 1/2, that's the same thing as square root of 2. You don't have to write that 2 out front because it's implied, and you don't have to write that 1 underneath because it's also implied. Okay, that should be a review. Does anyone have any questions though? Okay, I'm just gonna remind myself what time class is over. I'm sure you'll be thankful for that later. 10:50. Okay, good. We still got a lot of time. 10:50. Okay, so now we're going to get into 3.4, and it says write as a single logarithm. What we're technically doing here is we're using properties of logs. And I'll kind of list them above the problem so we can kind of have like a list at the top. And what this is basically doing is condensing. So condensing means to like make smaller or to like shrink down. So I'm gonna say make smaller. This means that we're putting it in just one log. So we're only gonna have the word log written once on all of these because we're taking like this longer equation and making it something smaller. And so there's a couple, I think there's like 3 different things that we can do in order to combine or break down these logs in order to condense them. So the first one is if I have a minus sign and I want to condense it down or put it down into just one log, minus means that I'm going to combine them by dividing. So I'm going to divide the 2 things that I'm doing the log of. So I would do log of x divided by y. And so you can write that up here as just like minus goes to division, or you can write it with more words. You can say subtraction goes to division, whatever makes you happy. If I write something on your notes and you're like, this wouldn't help me, don't write it down. You can always change what I write. But this is my final answer. My answers in this, at least in this section with condensing, is going to be like log with some variables with some numbers. Okay. The next one, it looks different because I've got a plus sign instead. When I have a plus, that means that I condense it or bring it down to one log by adding. Or sorry, it was adding, it's multiplication. Sorry, my head's a little confused right now. So subtraction goes to division. I could say addition goes to multiplication, or again, you can use words if symbols are not helpful. So I can say addition goes to multiplication. So if I have this addition sign, I'm going to combine them by multiplying. Before I do that though, I have this weird coefficient out front that I have to deal with first. When there's a coefficient, that becomes the exponent of my variable. So I'm going to write that. I'm going to say coefficient, and it goes to exponent. Coefficient goes to exponent. Okay. Coefficient goes to exponent. And I am going to do that coefficient to exponent before I do my multiplication. So I'm going to do log of x squared plus log of y. And then now I'm going to do that addition into multiplication, and I'm just multiplying the 2 things that I'm doing the log of. So log of x squared times y. Okay, I want a little feedback right now. So use your little emoji reactions. I want you to give me a thumbs up if you're like, yes, I've done this. Yes, I'm doing okay. I'm hanging in there. And I want you to give me like a little clapping if you're like, I'm not really sure, or this is kind of new to me, or I'm completely lost. So thumbs up means good. Clapping means a little bit slower, a little bit more help. Okay, I see 1 thumbs up, 2, 3, 4 thumbs up, a couple clapping, a couple thumbs up. Okay, very good. Okay, I have a mixed response, so I'm gonna keep going slow. If you feel good, you can move ahead of me and then come back and check your answers, but I'm gonna take this pretty slow, okay? These 3 rules that we've just talked about, subtraction to division, addition to multiplication, and coefficient to exponent, is what I'm using for the next 4. So letter C. I've got my coefficients, so let's deal with those first. So I've got to the 1/3, So I'm gonna make z go to the 1/3, and then I've got 2/3, so I'm gonna do w raised to the 2/3. So I've got log of z raised to the 1/3 plus log of w raised to the 2/3. Before I deal with that plus sign, let's actually do those exponents. So z to the 1/3 is the same thing as log of cube root of z. I think it's gonna be easier to do this now when they're separate versus waiting till they're together. And you'll see what I mean in a second. I'm also gonna do w while I'm here. So w to the 2/3 means it's also a cube root, but it means it's gonna be w squared on the inside of that cube root. So all I've done so far is made my coefficients exponents, and then I've just simplified those exponents by going from the fraction of the exponent to a radical. The last step I'm gonna do is I've got an addition sign, which means I'm going to multiply the two things I'm doing the log of. So I'm gonna multiply cube root of z and cube root of w squared. I don't know if I explicitly said this before, but when we combine them, I'm only gonna have one log, so the second log just goes away because I'm combining them down. And so I've got log of cube root. Since they're both under cube roots, I can put them both under one cube root together. So cube root of z w squared. And that's my answer. Sometimes they're super simple, like log of x divided by y, and sometimes they're more complicated like this one we just did, and that's okay. Okay, questions, concerns, comments so far? All right, the next one has numbers, which makes it look a little bit more complicated because we can simplify it down, but we're just gonna do our math, our algebra that we know on each step, and go slow, and hopefully that makes sense. Any questions on the first three so far? Okay. Let's do our exponents first. So I've got 1/2, so I'm gonna do 16 to the 1/2, and I've got 2/3, so I'm gonna do 8 to the 2/3. We're just gonna do one at a time. 16 to the 1/2 is the same thing as root 16. And we know the square root of 16 is just 4. Now I know I spent like literally all first semester reminding you that a square root is a plus or minus, it's plus or minus, don't forget the plus or minus, don't forget the plus or minus. This time we don't need a plus or minus because we cannot do log of a negative number. I'm gonna do like a small caveat off to the side. You don't have to write it down, but I do want you to listen. If you remember when we did our BFF graphs back in 1.3, we had y equals ln of x, a natural log graph, and it looked like this. It was kind of like this curved line, and there was never anything on the negative x side. I could not plug in a negative x and find any y value over here. That means that x, the number we're doing a log of or of a natural log of, can never be negative. The only thing I want you to take out of this is if you have a square root like we just did, your answer will always be positive. Any questions on that? Okay, now let's do the 8 raised to the 2/3. So I'm gonna do I want a pencil. Minus log of 8 to the 2/3. Remember that that means it's cube root of 8 squared. And cube root of 8 squared, I actually might need some of this space off to the side to do that. 8 squared we know is 64, and if I'm doing cube root of 64, if you remember our factor trees from Algebra 1, Algebra 2, whatever, a long time ago, we would break down 64, and if I can find 3 of any number, then I can take it out. So the easiest thing I know about 64 is it's 8 times 8, and 8 is 2 times 2 times 2, and the other 8 is 2 times 2 times 2. Well, that's 3 2s right there, which means that I can take out 1 2. And here's another 3 2s, which means that I can also take that out. When we take them out from under the radical, you multiply them together. So log of cube root of 8 squared is the same thing as log of 4. Now, because we're condensing it down, I've got this negative, which I know is going to be combined as a divide. So I have log of 4 over 4. And that's the same thing as log of 1. I'm going to go one step further. If we had log of any number rate of like log base 10 of 1, that equals 0. You also could have seen it right here, because if I have a number minus itself, they should cancel out and I should go straight to 0. But I wanted to show you the process. Technically, my best answer is 0 right here. Log of 1 will always be 0. Again, you see how I did a little bit more work there? When you have numbers, it can be a little bit more complicated or a little bit more work, because like we can actually simplify down. When we had Z's and W's, I can't do like cube root of Z and cube root of W squared. I don't know what those actual numbers are. So that's why we had to do a little bit more work here. Any questions so far? Okay, we got 2 more, and then we're gonna move on to a new idea. We've got another one with numbers, but I think this will go a little easier. Let's do my exponent or my coefficients to exponents first. So I've got 3 out front, so that makes it ln of 2 to the 3rd. And then I've got a 1/2 out front, which is the same thing as ln of 36 to the 1/2. Let's do those separately. 2 to the 3rd is just 8, so ln of 8. And then 36 to the 1/2 is ln of root 36. Well, we just did a root a minute ago, and I told you they always are positive, and I know that the square root of 36 is 6. So ln of 8 plus ln of 6 plus means multiply. So I'm going to do my multiply, my 8 and my 6, and I'm going to do that in my head. I know that that's going to be 48. So my answer is ln of 48. I know I moved through that one a little quickly. Does anyone have any questions? Okay, last one of this type. Again, I've got some coefficients, 4. When we do this, let's make sure that we're doing log of x times y to the 4th. If you try and give it, if you try to distribute through, you might mess that up. So I would just be very careful and write x times y in parentheses and then raise to the 4th, and then we'll deal with that in a second. And then I've got an exponent of 3 because I've got a coefficient of 3, which makes it log of x to the 3rd. Minus means that we divide them. So I'm going to divide x. Oh wait, no, I lied. I want to do one step first. The one step I want to do first is going to make it easier at the end. Before I divide, let's distribute this 4th inside. So that becomes log of x to the 4th, y to the 4th, minus log of x 3rd. You might have said, Miss White, I already did that on the first step. Awesome, good for you. Sometimes I mess that up, so I'm showing that in 2 steps. If you do it in 1, also great. Now I'm going to deal with my minus, which makes it to divide. So I'm going to do log of x to the 4th, y to the 4th, over x to the 3rd. Oh, and I can simplify here because I have x's on top and x's on bottom. Again, I know we spent time in quarter 1 or semester 1 sometimes doing exponent rules, but if I have an x on both top and bottom, remember that I can minus their exponents in order to find out what it would be simplified. So 4 minus 3 would be x to the 1st, which means I've got an x to the 1st on top and then a y to the 4th. Nothing's on the bottom, so I don't need a fraction anymore. Okay, any questions so far? Okay, let's keep moving. This was what I called condensing. The next one is expanding, which means that we are having something small and we're making it bigger. So we're essentially doing all of these rules just backwards. So on these problems, if we saw subtraction, we made a division. On the next set of problems, if we see a division, we're going to go to subtraction. on these problems, we saw if it was an addition, it becomes a multiply. On the next set, if it was multiply, we're going to make an addition. So we're essentially going backwards in this next group. So I have a multiply here because there's no sign between them, but it means that I'm multiplying them. When you split it up, you need at least two logs. You might have 3 logs, but every time I split it, it means that I have to have another log. So that becomes ln of x plus ln of y. When I put a plus or a minus, you got to put an extra ln or a log in. Questions on that? Okay. I'm going to go to the next one. Since I have exponents, but I have them separated by this division sign, I'm going to do the division first, and then I'm going to do my exponents. So we go backwards. If it's division, that means that it's subtraction. So I'm going to do log of x to the 3rd minus log of y to the 4th. And then now I'm going to deal with my exponents. Remember last time my coefficients became exponents, so my exponents become coefficients. So I've got 3 log of x minus 4 log of y. Am I moving too fast, or are we doing okay? Okay, I cannot see anyone, so I'm assuming we're good. Talk to me if you're not. On letter C, I've got this big radical over everything. So let's deal with the radical before we deal with the division. I've got log of x divided by y. If I make this radical into a exponent, it's a fraction exponent. It's a 5th root, so that means the 5 is on the bottom, and there's no coefficients on the x or the y. There's no exponent on the x or the y on the inside, so I'm just going to make that a 1. That makes it a little easier to digest because I've got a 1/5 as one exponent. So let's deal with our exponent first since it's in charge of everything. We'll bring it down to be my coefficient. 1/5 of log of x divided by y. And then now we have to do our division. So I've got 1/5 of log x and then minus. I don't get to just put log. I have to bring that coefficient with me because it also went to the y. So I'm going to do 1/5 log y. The 1/5 goes to both the x and it goes to the y. So I have to put the 1/5 with log x and the 1/5 with log y. Any questions so far? Okay. Next one is log of 4th root of x divided by y. Well, in this one, the 4th root doesn't go with the y. So let's divide them, let's separate them first, and then we will do the radical. So division means I subtract them. So log of 4th root, of x minus log of y. I know the 4th root of x is the same thing as x raised to the 1/4. And then my last step is to bring that exponent as a coefficient. So out front, since the 1/4 only is with the x, it doesn't go to the y, it only goes to the x. 1/4 log of x minus log of y. Oh God. Questions, comments, concerns? Okay. We got 2 more, and then I want to show you something small on the calculator. Log of 100x squared. Well, we know that there's a multiplication in here because 100 times x squared. Let's separate it with a plus. Log of 100 plus log of x squared. You're not going to love this, but I want to do things the most correct way, and not the easy way. If I have 100 or if I have something that's a perfect square, we're going to make it a perfect square. We're going to break it down to what that is. So 100 is the same thing as 10 squared. We all know that. So we're going to do things the most right and make that 100 10 squared. So now I've got log of 10 squared plus log of x squared. And then I'm going to now bring all my exponents out front. If it's not a perfect square, you can leave that number as it is. But since it is a perfect square, we're gonna do it the most right, and I'm gonna do 2 log of 10 plus 2 log of x. Any questions? The last one also has a number, but it's 30, and 30 is not a perfect square. So we're just gonna let 30 be. 100 was a perfect square, that's why we had to simplify it. ln of 30 e to the third. Well, that's a multiply because 30 times e to the third. ln of 30 plus ln of e to the third. Again, 30 can't be simplified down. My only exponent I see or I have or I can have is 3. So I'm going to do ln of 30 plus 3 ln of e. Okay, any questions? Okay, this next problem, we're going to need a calculator, so I'll have to switch my screen in a second, but I want to talk about it first. It says evaluate, and it says round to the 10,000th. Anytime it says round, that's kind of like a little key to like use our calculator. Use your calculator. Normally we've done problems like this before, and I told you, okay, set it equal to x, log roll it, so we'd have like 3 to the x equals 4. However, once I get here, I'm like, oh shoot, I don't know what power 3 needs to be raised to in order to equal 4. It's not an even number. It's not a decimal or fraction. Like there's nothing I know. It's going to be some weird thing that I don't know, and I'm going to have to find. What we're going to do is put this in our calculator. Now, when I was in high school, we did not have fancy technology, so we had to do a change of base. So I am going to show you what it is. Change of base meant that we made a fraction, and it was log of 10 or ln on both top and bottom. And the b, the base, went in the bottom. And then what we were doing, the log of went on top. So like when I was in high school, we had to like write this out, and then we could put this in the calculator because we could do log base 10 or log base e, whatever. Now you guys have fun technology on your calculator that can do log of a different number, log with a different number base. And so there's no reason for me to do this with you if we can do it in our calculator anyway. So again, you could use change of base. You maybe have heard that. You've maybe been taught it. But I think it's a little antiquated now based on our technology. So we're going to go just to our calculator and physically solve what this is. So you don't need that. And you technically don't need anything I've written. You'll just have a decimal, and that will be your answer. So I'm going to stop my share. I'm going to get my calculator up. I would highly suggest you use your calculator, or you at least follow along with what I'm doing, because I'm guarantee this will be on the next quiz, test, whatever we do. Okay. I think you guys can all see my calculator. If you go to the math button under alpha, you've used this menu before. Sometimes we put things into fractions. Sometimes we do cubes. Sometimes we do cube roots. You've seen this menu before, I think. We don't use it a lot, but you've seen it. If you scroll all the way down to capital A, so it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A says log base and then parentheses. Click on that one. This now gives you a little box under log and then a big box next to it. The little box is your base. So in our problem, I know you can't see my screen, but you have yours in front of you. It's log of 3, log base 3. And then we're doing of another number, and in this case, it's 4. Log base 3 of 4. This looks literally what my paper looks like. I've got a small number as my base. I've got a big number of what I'm taking my log of. And then you press enter, and that is just your answer. Your answer is a decimal. That's the end. So on my paper, I'm going to write, oh, it says round to the 10,000ths. That's 4 places after the decimal. So I'm going to write 1.261 and 85 rounds to 9. So I've got 1.2619 as my answer. Okay. Now you can do this for all of them, and we'll finish with this tomorrow. You can keep pressing math and then scroll down to A and then plug in blah, blah, blah. But sometimes that's a lot of work. So I also want to remind you that if you just press second enter, it just brings exactly what you typed the last step before. So if you don't want to keep going back to the math menu, you can press second enter and then change this. So like the next problem says log base 29 of 3. And so I really easily just change those numbers, plug them in, and then I can find that that answer is 0.3263. Okay. Okay, that is all we have time for. Does anyone have any questions right now? Okay, I'm going to stop my share.